Hi guys, welcome back to everyone. And uh, today we'll be discussing the banking and insurance analytics domain. And we have already discussed one of the use case when it comes to decision tree, and that is we have discussed in the insurance domain. In that case, what are the factors that we will be considering when it comes to insurance? Based on that use cases, we have performed few operations, and then we have come up with the predictions. Similar to that, here we'll be discussing about the same decision tree algorithm, but in banking domain. So we have one use case, and how we will be predicting, or how we will be doing the prediction for the default, who's going to default and who's not going to default. So it is one of the use case we'll be having when it comes to banking. We'll try to discuss what exactly that use case is, and how the decision tree algorithm going to work, and what are the mathematics behind the decision tree, and how it will be making the decisions. So what are the advantages we'll be having when it comes to decision tree over the other algorithms? We'll try to understand, and then we'll get into the use case. So yeah, without wasting any time, let's get into the session. See, when it comes to components, I'll briefly go through what exactly the decision tree, since we have already seen how decision tree will be working about on 6th day of the session. If you want, you can simply go through that, and with that, you can understand how the decision tree will be working, what are the components we'll be having, and which base it will be doing the classification. So when it comes to components, I'll briefly go through what decision tree is. A decision tree is a tree-like structure in which internal node represent the test and the attributes. Each branch represents the outcome of the test. So what exactly we are trying to say here? The root node. I mean, when it comes to decision tree, we have three components. One is root node, and then we have a branch node, and then we have a leaf node. Root node is responsible for the splitting of the tree, from where we have to start splitting. So we have various features. Let's say we have considered same case we'll be considering here. Let me show you that use case we will be talking about. So these are the use case, and these are the features we'll be having. So from where we have to start splitting, checking the balance. What is the balance and month loan duration? How many months loan duration you are taking? I mean, if you are going with some loan, in that case, what is the duration of that month loan duration? And then credit history will be having whether you have a good credit history or bad or poor, something like that. We have ratings, right? So then those ratings will be taken care of, will be considering, and then purpose. So what is the purpose? If you are going with a loan, what is the main purpose behind that loan? Whether you are buying a car, whether you are going for the furniture, appliances, various, how much is the amount that will be having? Saving balance, how much saving balance will be having? If you are working, how long it's been that you are working? Whether you are working professional or you have quit the job. And percentage of income, how much percentage of income is going for that to the loan, whatever, if it is having any outstanding loan. In that case, years at residence. So if we are staying at particular location, how long it's been that we are staying in that particular location? What is the age? And other credit, if you have any outstanding loan, you will be having house, whether you have your own house or you have a rented house. So it is comes under the collateral, right? It is also plays very important role in order to decide whether we have to give a loan to that particular person or not. Existing loans, if you have any existing loans, in that case, how many? And whether you have a skilled job or unskilled job, it plays also important role. Well, we are discussing when when we get into the coding, in that case, we'll discuss how it will be useful and all. These are the various features we'll be having based on that. We will be predicting that whether that particular person is going to default or not, or we have to give a loan to that particular person. So that if you know whether that particular person going to default or not. In that case, you can come up with like whether we should give a loan or not. So these kind of conclusions we can make once you done the prediction. So these are the features. So in order to build a decision tree, so what we are supposed to do, first we have to start splitting a root node. We will be considering one root node, and then we will be start splitting. But which features we have to consider as a root node? So we have two methods, right? We will be splitting. I mean, when you don't know which one you have to take, in that case, all the features, whatever the features will be having, all the features I am considering as a root node one by one. And then I will start splitting. Then I will start splitting. So every time if we will be taking the one feature as a root node, and then we'll start splitting. And what it is a root node, and we will be having the branch node. What happens? Internal decision. If you want to split the decision tree internally, in that case we'll be using the branch node, and then we have a leaf node. So terminal node, you can also call this terminal node. Based on these terminal nodes or leaf nodes, we will be calculating how many rules we have. When I am considering other credit or housing existing loan amount or the job, if I am considering this as a root node, job as a root node, in that case, how many rules we have? How many leaf nodes we have formed? Let's say using the existing loans count, you got like 15 rules. And I'm considering again a job, when that in that case we got 10 rules. So the algorithm that you're building based on existing loan count compared to this, it will be an effective model. In that case, it is having the maximum information. When you have a least rules, and it is giving the maximum information, that we will be deciding as the best decision tree. So these are the components we'll be having. How we can select one particular feature as the root node. For that, we don't know, right, which feature will be giving the good result. So we have very first method. We will be taking each and every feature as a root node, and then we'll calculate how many number of rules it will be forming. And then we have one more approach, that is entropy, calculating the entropy. We'll be discussing about the entropy in a minute. Before that, we'll go through how decision tree will be working. So this is how we will be coming up with. So this is how we will be selecting the which node we have to consider as root node, which feature we have to consider as a root node. So these are the components. First, we'll be having the root node, and then we have branch node, and then we have a leaf node when it comes to decision tree. Users training data to build model. What same when it comes to supervise? So decision tree comes under the supervise, right? So what happens when you have a supervise? Whatever the data will be having, the whole data will be simply converting into splitting into the train and test. Using the train data, I'll be training the machine learning algorithm, and using the test data, I'll be checking how good our machine learning model is performing. Based on that, whatever the accuracy that you are getting on train data and test data will be deciding whether it is good model or not. So this is the root node, and internal decisions are taken when it comes to branch nodes. These are all come from the branch node. So which variable to split at node, and what will be the value of the split? Decision to stop, where exactly we have to stop, and assign terminal nodes as a label. So these are the things we'll be considering when it comes to the decision tree model. So let me give you one example where exactly and how decision tree will be splitted. Wherever there is a chance to make a decision, in that case, we'll simply split it. Let's say one brief example we'll be taking. It is at 9 p.m. at night. So first question you'll be that will be getting in your mind whether you are hungry or not. If you are hungry, yes, in that case we have to go for dinner. If it is not, directly you can go with you can simply go to sleep. If you are hungry, in that case you have to go dinner. In that case, we'll be having option how much money you have in your pocket. If it is greater than 1,000 or not. If it is greater than 1,000, in that case, you will be going with some fancy restaurant, and then you will be having the dinner. If it is yes, in that case, you will be having dinner in fancy restaurant. If it is not, you can simply roadside cart something you will be having, and then you will go to sleep. And here then we'll be going to sleep. So just to, end is going to sleep. So in that case, what are the rules we'll be having? How many rules we'll be having? This is the terminal node, and is also terminal node, leaf node or terminal node. How many number of terminal nodes you will be having? That many rules we can form. Similar to that, one more example we'll take if it is not clear. You have a child and he's asking to let him go out and play. In that case, what are the conditions that you'll be checking? First, we'll check weather. What kind of weather we'll be having? Whether it is hot, whether it is chill weather, and it is rainy weather. So if it is chilled weather, in that case, you might not be having any concern. In that case, you can simply say go and play. So it is a one condition. If it is a chilled weather, you can directly say you can go and play. If it is hot weather, what is the temperature? Let's say it is greater than 38 degrees. In that case, you might not be allowing your child to play when you have this much hot temperature. In that case, you can say no. If it is greater than that, no. In that case, if it is less than that, in that case, you might be saying that, yeah, you can go and play. And when it comes to rainy, how much rain it is? It is too heavy. With that rain, is that wind also, a strong wind also coming? In that case, you will be looking into the various conditions. So here we have windy. In that case, you might not allowing him to play out. So no play. If it is not, in that case, you might be letting him to play. So just to let him play, what are the conditions we'll be having? These are the rules. In order to let him go and play, your children, if you are allowing your children to play, in that case, you will be considering these many rules. So each and every terminal will be leaving you one rule. So it is one rule, it is one rule, it is one rule, it is one rule. Like that, we have various rules. Yeah, like that, we will be having various rules. So whenever you are having the least rules, in that case, maximum information that node will be having. So this is how the decision tree will be working. So first we'll be splitting it, and then we will be trying to do the classification. So you can see the greedy algorithm, basic algorithm we will be having to decide which root node we are supposed to consider. Tree is conducted in top-down recursive manner. So wherever there is a chance, like we will be considering random feature, will be considering as a root node, and then we'll be splitting. And how many number of rules we'll be having for that, we'll be calculating that. Again, we'll be taking one more feature, one more column. Again, we are splitting how many number of rules we'll be having, that we'll be calculating. Like that, we'll be doing the same thing multiple times. Wherever you are getting the least rule, that will be considering as best fit. At start, all the training examples are the roots. So this is what I was talking about. At start, all the features, whatever the features we'll be having, will be considering as one root. Attributes are categorical. If whatever the inputs are, the feature that we are taking, if it is having any categorical, in that case, we will be converting into the discrete. Attributes are categorical. If continuous, values in that case will be converting into the discrete. If we have continuous, in that case it won't be taking. In that case, decision tree itself be itself converting into the discrete values. Or if you have any specific requirement that you want this age group in between this and this only, in that case yourself creating those bins. Yourself will be creating those discrete values. So whatever the continuous values will be having, in that case we can simply convert it into discrete values. Let's say what exactly that means. If you have a salary, I don't want that salaries to be considered as a continuous. Rather, what I will be doing, I'll simply categorize into just 2 or 3 categories: high salary, low salary, or medium salary. So whatever the continuous data, let's say salaries are 15,500. This is one more entry we have, 0.550. 75,500, 0.50. 85,500, 0.50. 50 or 2.50. These are all what continuous data. So if we have a continuous data, instead of taking as it is, I am simply converting into high salary. If it is, let's say, if the salary is more than 50,000 rupees, in that case, I'll be considering as high salary. If it is in between 35,000 to 50,000, in that case, I'll be considering as medium salary. If it is less than 35,000, in that case, I'll be considering as low salary. Whatever the continuous data will be having, I'm simply converting into discrete, that is low, high, and medium salaries. So if you have any continuous data, in that case, we'll be converting into low, medium, or discrete values you can consider. Input data is partitioned recursively based on the selected attributes. So wherever there is a chance to split it, the decision tree, we are simply splitting it. Test attribute in each node are selected on the basis of statistical measures, example information gain. So this is one method we will be having to come up with the inference, to come up with the rules, and we have one more approach, that is using the information gain. So in order to go with the information gain, you need to have understanding about the entropy. Entropy, what exactly the entropy is, we'll discuss in the next slide. So these are the how the decision tree algorithm will be working step-by-step process. Where exactly we'll be stopping. So keep splitting, and wherever there is a chance to split that tree, we'll be keep splitting. Where exactly we will be stopping. So here, let's say we will be considering whether that particular person will default the loan or not. So this is a use case we'll be having. So based on some features, the main feature will be features will be having it. Let's say we'll consider this. X1, X2, X3, and we have a status called whether that particular person going to default the loan or not. So the labels are all same. All are default. Say it is default. It is a default. It is a default. So all the labeled values are homogeneous. When you are splitting the decision tree, in that sub data frame, if all the labeled data is homogeneous, in that case we can simply stop. Why? Because we can able to make a decision. Whatever these features are, it is saying that it is a default, right? Whether it is going to default or not. He is going to default, he's saying. So the output is a homogeneous. In that case, we can simply start. All samples for the given node, wherever the node that we have started splitting, if it is all are belong to the same class, this is a class output we are talking about. In that case, we can simply stop. This is one criteria where we can stop the splitting. And there are no remaining attributes for that partition individuality. We have just one attribute left. And in that, we have default. So we don't have any attribute is left to split it again. In that case, also we can simply say, or if you have just one sample left, or there is no sample left, in that case also we can simply stop the splitting those trees. So these are the conditions to stop the splitting of that particular tree. Income. So see, this is how the normally decision tree will start splitting. First, income range of applicant. Let's say we are talking about the loan, whether we have to give a loan or no loan. Income of that particular applicant, if it is less than 30K, in that case, we will be checking others. If it is in between the 30 to 70K, in that case, what are the other rules that he has to follow? What are the other conditions he has to follow? If it is greater than 70, in that case, we will be having some other rules to follow. So, what are the rules that we are giving? If it is less than 30, is he have any criminal records or not? If he has any criminal records, in that case, we are saying there is low. If there is no criminal record, in that case, so it is not, we are deciding based on historical data we'll be having it. Based on historical data, it is coming up with the one pattern. Income range of the applicant is less than 30K and criminal record is S. In that case, no loan we are giving. It is a bit weird, but still, it is. We are not the one who's coming up with this algorithm. Whatever the historical data will be having, based on that, we will be coming up with. Income range of the applicants, if it is 30K, in that case, if not, in that case, we are not giving them no loan. If it is in that the income is in between $30K to the $70K, in that case, years in the present job, how long it's been since you are working in that particular job. If it is less than 1 year, in that case, we are not giving a loan. If it is in between 1 to 5 years, in that case, makes credit card payments. Do you make credit card payments regularly or not? We will be checking one more feature. In that case, yes, we'll be giving the loan. If not, in that case, we are not giving the loan. If it is your present, whatever the job that you are working on right now, if it is greater than 5 years, it's been greater than 5 years, in that case, we'll be giving the loan. And if it is a salary greater than $70K, in that case, we'll be again checking whether you have any criminal records or not. If yes, we are not giving the loan. If it is not, in that case, we'll be giving the loan. So how the decision tree is coming up with all these things? We are not the one who's coming up with. The decision tree will be coming up with this all based on the income of the applicant. So these are the rules. When income of that particular applicant, if it is less than 30K and if it doesn't have any criminal record, in that case, we are not. This is one rule. So this is one more rule, and this is one more rule, something like that. If you are considering income as root node, so present job, this is also one more feature. In that case, if you consider this, in that case, you might be getting some other rules. One rule, 3, 4, 5, 6, 7, 8. When you are considering the income range of the applicants as a root node, in that case, these many rules it is found. So like that, wherever there is a chance to split, wherever there is a chance to split, it will recursively, it will stay splitting the tree, and then it will be making the. That is the reason we'll be calling this decision tree as a top-down approach, top-down recursive approach. So here you can see there is one more way we can come up with the which are the features are having the much number of maximum information, you can say, attribute that results the most homogeneous branches. So let's say we have, in the previous example, let's say if the salary of that particular person in between the 30 to 70 or greater than 70, directly if you are saying you can directly give a loan. In that case, this feature is having the maximum information. If it is in between 30 to 70, in that case, we are not looking into any other feature. And directly, if you are saying, you can give a loan. If it is less than 30, in that case, we don't need to give a loan, something like that. Directly, if we don't need to consider any other feature, in that case, we can say that maximum information is present. Maximum information is present in that particular node. Like that, we'll be coming up with various inferences. Decision tree will be coming up with. This is one more approach, and then we have approach of entropy. So how we will be coming up with these approach, we'll try to understand. First, you need to have an understanding about the entropy. What exactly the entropy is? Measure of purity, measure of impurity also, you can say. Whether you can able to make a decision, how we can decide that how much purity it is having it, that particular node it will be having. Let's say if you are splitting based on one node, here you have there is a status, whether it is loan approved or not. Loan approved, we have no loan, loan approved, or we can simply take approved or not. Approved, no. Approved and no. So when you have something like this, here we have two approved classes and two no classes. Here we will be having highest impurity. Highest impurity. Wherever you are not able to make a decision, in that case we can say that maximum impurity will be having. So when you have two approved and two not approved, in that case, can we make a decision saying that we have to approve this loan or not? 50-50 opportunity will be having. In that case, you're not even guessing. You don't have even bias towards any one of these, approved or no approved. We have 50-50 chances. Based on the algorithm, based on the data set that you'll be having, can you say that if you have 50-50 chance, whether that is going to be approved or not? So you can't make a decision when you have a 50-50. So here we'll be having the highest impurity. Entropy talking about the impurity. So when exactly we'll be having the highest impurity? When you have a classes 50-50, you won't be able to tell whether you have to approve or not. In that case, we'll be having the maximum impurity. So maximum impurity will be having when you have 50-50 classes, 100% impurity. And if you have here no, instead of no, if you have approved. So here also we can't clearly take a decision, but when comes to no cases classes, we have approved classes where higher, right? In that case, we can say 0.8% impurity. In that case, we can say that it is having the 0.81 impurity. So here also we won't be able to take decision, but the decision is a bit of bias towards the approved, we can say, so that the impurity when comes to 50-50, it is 100%. When it comes to 75%, 25, in that case, it is about 81. So how we will be coming with the information gain? We'll try to understand here. Information gain, for the formula of information gain, it is entropy. It is the entropy, how entropy will be calculated. So when you have two classes, we have approved or not. So for that, if you have just two classes here, sigma is equal to 1. This is the formula when it comes to entropy. Here probability will be having, right, with respect to the class. So minus P approved log 2, that is P approved. The probability with respect to the approved classes minus P not approved, isn't it? Log 2 P not approved. So we'll be having probability with respect to the approved one. We have to take into the consideration into log 2 of again probability of the approved minus probability of not approved log 2 of probability of not. So we'll be taking this and then we will be calculating the entropy of. So how can we come up with the information gain in that case? So we'll be considering through entropy before splitting minus entropy after splitting. This difference will be calculated as information gain. So the same entropy will be calculating the before splitting. The whole main data frame will be having, right? So main data frame based on the classes will be calculating the entropy first. And again, we will be splitting based on any feature, any one of the feature will be considering, and then we will be splitting. So before splitting, it will be the same for all the features. After splitting, it will be changing. Entropy will be changing. That difference each and every time, if you are taking the various features, and then if you are splitting the tree, in that case, we'll be having various entropies. Those difference will be taking that into the consideration. Based on that, we will be deciding that how much information gain we will be having. Entropy before splitting minus entropy after splitting results in information gain. Result in information gain. And then we will be saying that wherever you have information gain is high, wherever you have information gain is high, in that case, maximum information is holded, maximum information will be having in that particular feature. Let's say x1, x2, x3, x4, these are the features I have considered. So overall entropy, I'll be calculating that entropy before splitting, and x, considering this x as a root node, I'll be splitting the decision tree. For that, I'll be having entropy after splitting when I'm considering x. Same entropy before splitting, again entropy after splitting when I'm considering x2 as a root node. Something like that we'll be calculating, whichever having the maximum information gain. This is only will be calculated as information gain. Wherever you are getting the maximum information gain, that I'll be considering as best decision tree. So we are looking at the decision tree in such a way that we will be asking the less questions and maximum information we have to get. Like it is kind of a hybrid model. The height of the decision, height of the tree, of that height of the mango tree is small, but we need to have a maximum yield. So this is like a kind of hybrid mango tree we are looking for. So we'll see what is the use cases, and we'll try to understand how the decision tree will be applied, how we will be importing it, and all those things we'll look into. So let's say, yeah, these are what are the required libraries I need to have. I'm simply importing those. So pandas, when we will be using the pandas case, manipulations, data manipulations. For data manipulations, I'll be using the pandas. So I'm simply importing those pandas library. And then in order to do the mathematical calculation, we'll be using the NumPy. So I'm importing the NumPy as well. So importing NumPy as NP, and then pre-processing. So so many categorical data will be having. I want to convert into discrete. In that case, I'll be taking the label encoder. So I'll be going with the label encoder since it is a very base model. If you want to try it, in that case, you can go with appropriate encoding techniques. We have it, one-hot encoding, we have label encoding. Anyway, I'll be going with the label encoding, and then we have a dummy variable creations. dummy variable creations will be having various. Will be having. You can go with any one of those appropriate encoding techniques. You can go with, and matplotlib in order to do the visualizations. In order to do visualizations, I'll be going with matplotlib. So run it. I have already. I'm using the Google Colab. So I have already uploaded the data set. The same path I'll be giving here using the pandas. I'm reading that particular file and I'm simply saving into the data. So it is a memory pointer. So the data, whatever the data I'll be taking, it will be stored in this. So run it. You can see these are the features. So these are absolutely necessary features to decide whether whether we have to consider that particular feature or not. So what are the features we'll be having here? Job dependency, how many people dependency you have. Like if you are, you have a children, in that case, those people will be coming, considered as dependents. Or if you have a, parents, and you are the only one who's working in the house, in that case, those, parents also comes under the dependents. And phone, whether you have a phone or not, whether this is the default, whether that particular person is going to default or not. It is a target variable I'll be having. And job, what kind of job will be having? If you have a skilled job, in that case, I mean, an unfortunate events happening like recession. So what happens in that case? If you have lose your job, in that case, you don't need to struggle much. If because you are doing a skill job, in that case, you have experience, this much experience. If you have, in that case, you can easily get a job. But if it is not a skill job, in that case, you have to start from the scratch, right? So it is also an important feature to consider when it comes to say whether that particular person will default or not. And we have one more, that is the phone, whether that particular person has a phone or not. But for now, I don't think it is a required feature, because nowadays everybody will be having the phone. So I'll be dropping that particular feature. So it is not necessary for now. And housing, whether you have your own house or you have a rented house. House, if it is own or other cases will be having, will be considering those features. And existing loan card, how many we have, how many loans you have you having any outstanding loans, or what is your age, and years at residence, where exactly you are staying. If you are a constant, I mean, it's been like years you are staying in what particular place, in that case, default, chances of default is very less, compared to less, in that case, we will be considering as years at residence also is a good feature. Percentage of income, how much percentage of income, whatever the loan that you are going with, how much income will be having, how much percentage of EMIs that will be getting into the loan. So that is also will be checking. Employment, how long you will be working. If you have years of experience will be having, we are simply taking into discrete. If it is greater than 7 years, it is one criteria I will be taking. 0, 1 to 4 will be having one more, 4 to 7. So we have a discrete data only. I'm simply converting into discrete, or you can create one bins. So in that case, decision tree, when you have these kind of values, in that case, it will make decision much better. Amount, how much amount you are going with the, what kind of loan will be having, how much amount you will be taking in thousands, let us say. Saving balance, if you are having, how much you will be having. And purpose, what is the reason behind it? Are you going with something that will be useful, or you are simply just wasting money? That is also, it is one good criteria to judge whether you're gonna pay back the loan or you're gonna default. And credit history, in order to sanction one loan, in that case, we will be going to the credit history, right? So credit history, we have various third party that is giving the credit history. So based on that, also you can judge. So how long that loan duration will be having, whatever the loan that you are going to take, how long the duration, that is also one criteria we'll be looking at. And checking the balance, how much balance you have in your account. That is also criteria, right? So these are the features I'll be considering. These are all the input features I'll be considering to say whether that particular person going to default or not. If you know that if he's going to default on that, in that case we can say whether you're going to approve that loan or not. You can take a decision that is done by the management. First, I'll be checking whether I have null values or not. You can simply take one feature and you can do, or you can, if you want, in that case you can take multiple features as well. So null values, whether you have any null values or not. So I'm checking the null values. I don't think I have any null values because all are zeros only. And then if you have null values, in that case you can use drop NA function. Since we don't have any null values, so we don't need to get into that. And columns, what are the columns we'll be having? If you want to check, so these are the columns, right? These are the columns we'll be having. And phone, I don't think it is necessary for me. So what I'm doing, I'm simply dropping using the drop function. Data, the main data will be having a data frame. From that, I'm dropping the phone. So you can simply run it. And now if you find out, if you find out the data frame, I mean, what are the features we'll be having? Data dot head. In that case, we'll see what are the features we'll be having. So you can see here, phone has been removed. What are the phone features I'll be having? I've dropped it. And then see what are the various data types we'll be having. You can see, you can go with the info. So what kind of data type each and every feature holding? To understand that, you have to go with data dot info and run it. So we can see object. So checking balance, it is an object we'll be having. Months to loan duration, it is also it is integer we have. Credit history, it is also object, and purpose is also object. Wherever we have a categorical data, that is textual data, I'm trying to convert those into numerical. Using what? We can use dummy variable creation. You can go with one-hot encoding. So I don't want to get into details. What are the dummy variable creation? What are the one-hot encoding? Various encoding techniques will be having it. I don't want to consider all those things. What I'm doing, whatever the categorical data will be having, I'm simply converting into numeric. So you can see converting the whole. I'm simply invoking the label encoder. Checking balance, it is a object data, that is categorical data. Credit history is also the same. Purpose is also the same. In that case, I'm converting everything into label encoding. I'm converting everything into label encoding. Now we can see encoded data. Whatever the categorical data will be having, I'm converting into the numerical, right? So that data, if you want to look at data dot head. Head function, what it will do, it will simply give you FAST5. What are the FAST5 data will be having? Entries, it will simply show. So you can see here. So we don't have any numericals. So all the data has been converted into, we don't have any categorical, all the data is converted into label encoded. So is it the best practice? No, we have to go with the appropriate encoding, but I'm simply going with the label since I'm doing the very base model. Default, this is a target variable I'll be considering, all are input features. So since it is supervised, we will be having the output. So what is the output here? Default. It is in the form of categorical. Categorical means whether we can go with the classification or regression. It is a classification algorithm. When you have an output, in that case, we will be going with supervise. If the output is categorical, or we can say discrete, we'll be going with classification. So if the output is continuous. So in that case, we will be going with regression, right? In last class, we have seen what is the regression, and when we'll be going with regression, what are the factors will be considering when it comes to regression, what are the assumptions, so all those things we have seen. Output is continuous, in that case, we'll be going with regression. Since here output is categorical, in that case, we will be going with classification. So first we'll check, whenever you are going with the classification, you have to check whether you have a balanced data or not. So data default will be having, and I'm checking how many unique values we have. Default, this is the feature. In that, how many unique values we have, that I'm checking, and you can run it. So how many we have? Just 2 unique values we have. One is no and one is default or not. Just 2 categories will be having, 2 classes will be having. And since it is a classification, so what else we need to look into? Whether it is balanced data or not. Whether it is balanced data or not. So how do we know whether it is balanced data or not? So we have rules, thumb rule. If it is binary classification, first we'll be checking 70% data, any one of the classes. Let's say it is the S or no. 2 classes will be having. Any one of the class shouldn't be 30% of the whole data. Any one of these shouldn't be less than 30%. In that case, I'll be correct as unbalanced or imbalanced. You can call any imbalanced or unbalanced data. If it is less than 30, unbalanced. If it is 30, even 30 will be considering as balanced. 70% for training and 30% for testing, or vice versa, or you can simply, or 40, 60, that is also comes under balanced data. So minimum you should be having at least 70% of any class, whether it is S class or no class. When you observe this, no, whether that particular person going to default, no, he's not going to default. In that case, we have 700 cases, and he's going to default. In that case, we have 300 cases. So in that case, we can say that 70% data is having the no, and 30% will be having yes. So we can consider it as a balanced case. We can consider it as a balanced case. So for now, we have to split which is the target variable and what is the input. Predictors. What are the input features we'll be having? What are the output features we'll be having? We have to split it. So when you are splitting it, what are the features? Predictors. What are the predictors? Means inputs. What are the inputs we'll be having here? So these all comes under inputs only. All the features, checking balance, month loan duration, credit history, purpose, all comes under inputs. That is input features, and the default will be having this only target feature will be having. So target feature as a default, and rest all should be in the input feature. So what I'm giving here, predictors, column names up to 15. Up to 15 means dependents. Till dependents I'll be considering as input, and the last one, 15th one, I'll be considering as output. So you can see if you run it. Yeah, you can see here what are the predictors will be having. If you run it this one, just only this, in that case it will result what are the predictors will be having. So these are inputs. If you run this whole just target column, in that case you will be getting what is the dependent. You can simply take one more. Control C. So target is column name 15th, the last one, and these are the input features. These are all input feature, or you can simply mention a target. In that case, we'll be getting the output. What output we have? So what is that? Output is a default. It is a target variable, and rest are all will be having as an input. So now what I'm doing, splitting the since it is a supervised model, right? So what we'll be doing when it comes to supervised model, whole data, let's say 1,000 data will be having. Here we have 1,000 data only. Will split into train and test. So what we'll be doing in train, whatever the data will be having, I'm considering 80% data for train or 20% for test, or you can consider 70% or 30% based on the availability of data. If you have 1 million data, 1 million samples if you have, or records you have, in that case you can go with 90% for the train or 10% for test also you can go with. Based on the data availability, it is not like we have to go with 80-20 or 70-30. Instead, based on the availability of data, how much data is available with you, based on that we can consider how much we have to consider, how much data we have to give for the train, how much we have to give. Before that, we have to import from SQL model selection, import train test split. So I'm splitting the whole data into train and test, and here I'm giving the test size is equal to 0.3. When you are giving the test size is equal to 0.3, automatically train it will be taking, that is 70%. So I have split the data into train and test. I've given test size is equal to 30% of the data. That means 300 data will be taken for the testing, and 700 will be taken for test train. So since I am going with the classification, so we have to import the classification algorithm from sklearn package. From sklearn tree, import decision tree classifier as a DT. So short form as a DT I'm importing. I'm using the DT wherever that is required. So model DT criteria, on which base I'll be doing entropy, and maximum depth I'll be using. These are the parameters we'll be having. We have various parameters. Where exactly it is performing better. In that case, we'll be doing the multiple iterations. Maximum depth, various values will be taking wherever it is performing better. When it comes to parameter tunings, we'll be doing that. So I'm taking the maximum depth is equal to 8, and then I'm fitting whatever the x values predictors will be having. I'm simply fitting, and with train data, it is a train data, train predictor and train target. I'm simply fitting into the model. First, we need to import it, and then you have to yeah. So what we have done here, based on entropy based on entropy only we'll be doing that, right? We'll be calculating the which root node I have to consider, something like that. We are going to. So I'm simply plotting whatever the classification that we are doing. So it's not giving much. Yeah. So this is a decision tree, how it is making decisions. So each and every condition it will be taking into the consideration, and then we'll be making the decision tree. Let's say here it is taking one feature, and based on that it will keep splitting. So you can see these are the rules. The terminal nodes will be having it. These all we will be calling it as root, as a rules. Each and every, in order to come up with whether you have to give that particular person role or not, this many rules we have to go with. So among those, I mean, it is not directly coming up with that particular, only this particular root node. It is going through various multiple iterations it is doing, wherever it is giving best, least number of rules. These are the least number of rules it is coming up with. So you can see predictors, if you do the output that you are getting. Yeah, the very first person is not going to default, and there is going to default. It is when it comes to train data. And so whatever the output that we are getting, so how good those outputs are, whether we can rely on those or not. In order to do that, in order to come up with that, we need to do the evaluation of the model. So how much values we have? We have how many inputs we have given, what are the actual outputs we'll be having, and what are the predicted output we'll be having. Actual and predicted will be comparing that. Based on that, we will be coming up with one accuracy of the model, how good our model is performing. So for that, we can go with the confusion matrix to evaluate the model, or you can go with the crosstab. Both are will be giving the exact values. So what I'm doing here, actual data and predicted data. So you can see actual and these are predicted. No as classified as a no. This means exact classification it is done, and yes, it is classified as, in that case, it is a exact classification. It is this diagonal are correctly classified, and this diagonal will be having misclassification. To find out the accuracy of the model, what we'll be doing? True cases, I mean true classification by total. So what we'll be having here? So 161 plus 49 by, these are the two classifications we've done, right? Plus 161 plus 49 plus 36 plus 54. So when you calculate this, in that case, you'll be getting the how much accuracy that you are getting. So true classification by total. If you run this is the accuracy that you are getting, 0.7. Each time you are running, in that case, it will be giving various accuracy, because when it is fetching the data, overall 1000 data entries will be having, right? Among that, when you are splitting into train and test, every time when you are running that algorithm, different randomly it will be picking, right? So different data will be getting. So here how much we'll be getting? Test it is giving 0.75. And the same I will be doing the prediction on train. In that case, how much it is will be giving, we'll see the predictions. So how much we are giving? It is train accuracy, it is about 87. So train accuracy it is giving as 87, and test accuracy it is given 0.7. That is 70%, and it is 87%. So huge difference will be having in between. So it is a bit of overfitting model. So we have various parameters when it comes to decision tree. Various parameters will be having. Hyperparameter units we can do. Hyperparameters tuning we can do, and we can change. We can decrease that overfitting value. Or else, whatever the features we are considering, is it is are the only features we'll be having, or we do have any other feature to be added? So we'll be doing the analysis, and then we'll be coming up with a good model. Like that, we can. This is how we will be applying the decision tree model when it comes to real time. So since we have taken the banking, so it is a banking example. It is this algorithm very frequently will be used, guys, when it comes to banking. Whether it is very important, bank should know who's going to default, because nowadays NPAs are non-performing assets are increasingly very there is surge. So in that case, it will be difficult to maintain a bank. So they have to decrease NPA cases as much as possible. That is the reason they are looking for the model that will detect who's gonna default the loan, who's gonna not gonna default the loan. In that case, they can optimize those. They can simply eliminate those NPAs, or you can avoid those NPA cases in the future. So this is a decision tree model, guys. When it comes to banking, these are the features we are considering. Based on that, what we are doing, we will be predicting whether that particular person going to default the loan or not. Yeah, that's it for today, guys. And I hope you guys have understood what exactly the decision tree and how we'll be implementing this. We haven't touched much about the decision tree because we have covered in the 6th day itself. If you want to, you can go through that. And this is one of the use cases. At that time, we have considered the insurance data we have considered, and this is the banking use case, and how we will be implementing the decision tree when it comes to banking use case, since we will be covering the domain of banking and insurance. So it is one of the banking use case that you want to go through. In that case, you can go through. So yeah, that's it for today, guys. If you want, yeah, once it is done, yeah, we have done with the how decision tree will be implemented. And in next session, we'll be coming with one more algorithm and use cases as well. If you like this content, in that case, you can follow with the next session as well. And yeah, thank you for joining us, and we'll see you in the next session. And meanwhile, if you are interested in the data science, in that case, you can contact these links that are provided below. You can directly get into the 360DG homepage, and whichever the domain that you are interested, or whether you are interested in data science or data analytics, you can simply go through and you can contact a respected salesperson. So that's it for today, guys. We'll see you in the next session, and until then, have a nice day.